Imagine looking into a mirror that doesn't just reflect light but time itself. Not your own reflection, but a glimpse into the universe's earliest moments when existence was still catching its breath. That's exactly what the James Webb Space Telescope was designed to do, but what it found wasn't the infancy of the cosmos. It wasn't the quiet dawn of creation. It was something else entirely, a paradox. What Webb uncovered didn't just surprise astronomers, it shook the foundation of modern physics. For decades, scientists believed they had a solid timeline. The Big Bang, a long cosmic dark age, then the slow formation of stars, galaxies, and eventually life. The deeper you looked into space and, thus, into the past, the simpler things should be wisps of gas, chaotic light, unformed matter. But when Webb aimed its golden mirrors at what should have been a quiet, dark corner of the sky, it saw something that should not exist, a fully developed galaxy. Not a faint smudge or a loose scatter of stars, but a complex spiral galaxy, structured, rotating, and anchored by a massive black hole at its core. It was mature, it was stable, it was thriving, and it wasn't alone. As data streamed in, more ancient galaxies appeared organized, chemically evolved, gravitationally sound. As if the early universe had skipped ahead billions of years. It was like opening a history book to the first page and finding cities, skyscrapers, and civilizations already built. And with each new discovery, one terrifying question grew louder. What if everything we thought we knew about the beginning is wrong? Webb's first image of that mature galaxy, sitting over 13 billion light-years away, was expected to be barely distinguishable from background noise. But instead, it revealed a cosmic marvel, spiral arms glowing with starlight, dense clusters in ordered motion, and a blazing galactic core. This wasn't a galaxy forming. It was already formed. According to our current models, that's impossible. Galaxies should emerge gradually from scattered matter, pulled together over billions of years. But what Webb showed was a galaxy that had already completed that process less than 400 million years after the Big Bang. It's like finding a full-grown redwood in soil just planted yesterday, and it wasn't an isolated event. Webb found more galaxies like it across different regions of space, all showing maturity far beyond what the timeline allows. The telescope was working perfectly. What wasn't working was our understanding of the universe. Then came the next shock. Spectral analysis, the DNA of light-revealed elements like oxygen, carbon, even iron, these shouldn't have existed yet. Such elements are forged in stars, scattered by supernova, and recycled into new generations. That cycle should have taken hundreds of millions of years. But these galaxies had already gone through it more than once. The early universe wasn't crawling toward complexity. It was sprinting, and it gets stranger. At the center of one of these ancient galaxies was a supermassive black hole 1 billion times the mass of our Sun. Today, that's remarkable. But back then, it's unthinkable. Black holes grow slowly, over billions of years, feeding on gas and stars. But this one had no time to grow. It just was. Even our fastest simulations can't explain it. It's like discovering a grown adult who was born an hour ago. The math breaks. The logic collapses, but the data stands. So scientists began exploring the unthinkable. Some now suggest that black holes could have formed immediately after the Big Bang, born from extreme density fluctuations, primordial black holes. Others think dark matter, long believed to be a quiet gravitational actor, might have aggressively sculpted the early universe, acting as scaffolding to build galaxies faster. And then there's the most unsettling theory of all. Misunderstood the flow of time itself. Perhaps in the early moments, time behaved differently, stretched, twisted, accelerated, allowing eons of change to pass in what looks to us like a blink, or maybe, just maybe, complexity isn't the endpoint of the universe. Maybe it's how it all began. As the data continued pouring in, researchers began to notice something even stranger, something unrelated to brightness, mass, or conventional classification. It was the shapes, patterns hidden in plain sight, using deep learning algorithms to analyze the structure of ancient galaxies. Scientists uncovered an astonishing truth. The spatial distribution of these distant systems wasn't random at all. They followed a precise, repeating mathematical ratio, one eerily close to the golden spiral. This wasn't just aesthetic beauty, it was architecture. a hidden geometry stretched across billions of light years, linking stars and galaxies in a grand design. Spiral arms, orbital distances, rotational symmetries, what once appeared to be chaos now resembled a fractal code, a recursive logic echoing across cosmic scales. It was no longer plausible to call it coincidence. The early universe, once thought to be a turbulent, shapeless explosion, was starting to look engineered. Fingerprint patterns. But fingerprints of what? A fundamental law, deeper than physics, or something far more unnerving, evidence of written into space-time itself. One of the James Webb Space Telescope's most controversial discoveries didn't come from a black hole or a distant quasar. It came from nothing, a void, a stretch of interstellar space so ancient and empty it was assumed to be sterile, a graveyard of light. And yet, Webb's ultrasensitive spectrometers picked up something no one expected: complex organic molecules drifting freely in the dark. Not methane, not ammonia, but polycyclic aromatic hydrocarbons, molecular frameworks that form the backbone of amino acids and, by extension, the blueprint of life. These weren't clinging to a comet or hidden in a planetary nebula. They were free-floating, undisturbed, for 13 billion years. Still intact, the implications were staggering. It meant the ingredients of life didn't evolve later, within solar systems like ours. They were there from the beginning, baked into the chemistry of the early cosmos. Life, then, might not be a rare planetary accident. It might be a feature of the universe itself, not an exception but a rule. And then came the image that silenced even the most hardened skeptics. Deep within a cluster of high redshift galaxies so ancient their light was nearly lost to time. Webb captured something so precise, so mathematically perfect, it defied every natural model. 6 galaxies, arranged like petals around a central object, each spaced evenly, each rotating in synchronized harmony like a cosmic dance, choreographed with impossible elegance. They called it the flower. Some insisted it was a trick of gravitational lensing. Others blamed turbulence from the early universe, frozen into structured by quantum symmetry. But behind closed doors, a few began to whisper the unthinkable. What if it wasn't a coincidence? What if it was a message, a signpost? Not to be interpreted, but simply to be seen, a calling card left in the deep, meant to be witnessed only when a civilization's eyes had finally opened wide enough to understand what had always been there. And finally, the most unsettling theory to emerge from all of this, that simply observing the ancient cosmos may be altering it in return. This is rooted in the observer effect from quantum physics, the idea that the act of measurement can change the outcome of an event. But what if this concept doesn't just apply to particles? What if the universe, at some incomprehensible level, responds to our awareness? By building the James Webb Space Telescope and gazing with unprecedented clarity into the early universe, what if we didn't just see something? What if we stirred it? What was once dismissed as speculative philosophy is now being cautiously explored by a fringe of physicists. They've noticed patterns in Webb's data patterns that seem to subtly shift over time depending on how, when, and even why they're analyzed. Some images appear to change, not due to technology or error, but as if the universe itself is reacting to being noticed. If this is true, it changes everything. We are not passive observers. We are participants, active co-creators of the very reality we seek to understand. Because what the James Webb Telescope uncovered wasn't just distant stars or ancient galaxies. It was something deeper, something woven into the bones of reality itself. A truth so ancient, so vast, that simply perceiving it may be enough to shake the foundation of space and time. We didn't just detect the unimaginable. We may have unlocked it, not through force, but through focus, by daring to ask questions that no species before us had the tools or the curiosity to even imagine. Galaxies too evolved, chemistry to refined, structures to precise, and signals that seem almost ... aware. Webb didn't just show us that the universe is more complex than we thought. It suggested the universe may be aware that we're watching. Maybe we didn't find the edge of the cosmos. Maybe we found its memory. And maybe it remembered us. So the question isn't, what did Webb see? The real question is, what saw Webb? If this gave you chills, if the patterns felt too intentional, the discoveries too perfectly timed, the silenced responsive, then you're not alone. because the next piece of the puzzle might already be incoming. Turn on notifications, because the universe might not be done whispering. Share this with someone who still believes space is quiet. And comment below. Do you think James Webb discovered something ancient, or did something ancient discover us?